Okay, guys, our recording is up and running. We can begin today's work. And just to confirm, just give me a thumbs up if you can hear me, and you can also see my screen. Very important. Awesome, guys. Let's get moving. Okay. So in this session, guys, today's session will be looking at a brief overview of what you were supposed to take away from your Maths 1, especially to start the first chapter of your Maths 2. And then we'll also look at your introduction to some concepts which are related to Maths 2. And as communicated, today we'll be focusing on calculus. So we'll focus on 3 topics. The first one, which is very important, because for the first week or 2, you'll be working with this, is the first order differential equation. And secondly, we need to look into linear operators. And then thirdly, we need to look into the D operator notation, how it works, when do we use it, and how do we use it. Okay, I see I have a hand from, let me see. Nakedi, you can go ahead. Do you have a question? Okay. I cannot see you unmuting yourself. Let me carry on and jump into our first order differential equation, guys. And as you know, during the course of this lesson, whenever you do not understand, you should make sure that you do stop me and you do ask questions. Okay. So let's go ahead and have a look at the first part, which is looking at what you learned when you were doing first year, which is called the first order differential equation. So let's start there and look at a first order differential. And guys, please keep yourself muted unless you're asking a question, okay? I can hear some background there. So let's have a look at the first order differential equation. In fact, it is not a first order. There's a first order because for your course, guys, you'll be dealing with linear differential equation. So this is what we are going to be looking at. So my handwriting, don't worry, it will catch up. So we're looking at 1, it is a first order. And then secondly, and very important for you guys, it will be a linear differential equation. So you shouldn't go and worry about looking up on the internet and do problems that are not relevant. You will not deal with non-linear first order differential equations. So the first part which we need to look at whenever we are dealing with the first order linear differential equation is to look at the standard form, because you need to be able to spot it. So the standard form, how does it look like? Well, any differential equation, guys, that takes the form of dy dx plus, let's say, p of x times y equals q of x. Any differential equation that can be written in this form here, we'll call it a first order linear differential equation. Why is it a first order? It is because the highest derivative here is 1. So if you look carefully, our highest derivative is equal to the first derivative. So that is why we are going to say this is a first order differential equation. Guys, please mute yourself, okay? Unless you're asking a question. It's not good to make some background noise. Just look at your mic and do justice. So that is why this is called the first order differential equation. First, because the highest derivative is the first derivative. Why is it linear? We'll explore that later, where the linear part comes in. But this is the standard form of a linear differential equation. If there's any first order differential equation that we can write in this form, then we can say it is linear. Okay. Then the next question which we need to ask ourselves is, how do we solve first order linear differential equations? So how do we solve our first order linear differential equation? So you'll see they'll be using LDI now and then. Okay. So let's try and answer this question because you've done this. So the first step, I'll give you a couple of steps. So step number one, what you need to make sure is that our differential equation is written in standard form. Remember what I said is standard form, guys. It is the form which we see here. So the first thing you need to do as part of your solving is that you need to make sure that the DE is for differential equation is written in standard form. So that is very important. And remember what is standard form? I gave it to you above, so I'm just going to copy it and paste it down here. So that is the first thing you need to do. And you'll see when we do problems that it's not always in standard form, so you need to do some gymnastics to get it to be in the correct form. So secondly, once you are able to write it in standard form, which is what we have here, you then need to identify some parameters. So which ones? So you need to identify P of X and Q of X. So look at where P of X and Q of X are, guys. You look carefully, P of X is whatever that multiplies Y when we write our differential equation in standard form, and Q of X is whatever which lies after the equal sign, whatever which we see after the equal sign, that is Q of X. We need to write down those, identify them, and then say P of X is that, or P of T or Q of T, depending on what the independent variable is. Okay. And number three, after you've identified the P of Q and the P of X and Q of T, we need to determine or find there's a term that we are going to introduce, which you guys should be familiar with, something that is called the integration vector. What is this integration vector? Well, it will be represented by a sign that is like mu, but we need to go and figure out how do we find this. And many of you probably remember this, but I'll remind the few who forgot. So the integration factor, guys, which is depicted by this sign, will always be e to the power of the integral of P of X dx. So do you see why we needed to understand P of X? Because when you now look at our numerator, we now need to integrate there, not our numerator, but our exponent. We need to integrate that P of X and then make it to be the power of E. So one thing I want to remind you guys, or maybe to make note of for you, is that when you do this integration here, you do not need to write the plus C. I think first year we were doing that a lot, but just make a note of that. You do not need to write plus C. You will see when we start working out problems. And the reason is very simple. The effect of plus C will eventually be cancelled later. So we don't want to have extra steps that are not going to be useful later. So make a note of that we don't have to write the plus C, okay? But we would have found the integration factor. So after finding the integration factor, what do we need to look at? Number 4, you can now start solving for Y. So here you do not need to go and show how we move from Y or from the standard form to eventually go to Y. So the fourth step, we need to solve for Y. And I want to remind you guys that whenever they say solve a differential equation, if we have dy, it means what they are looking for is y. So whenever they are saying solve a dE for differential equation, and let's say in that differential equation you have dy dt, all what they are saying is solve for y. Okay, so it means when they give us a problem and then say solve the differential equation, we need to look at what are we differentiating, and that is what we are trying to solve for. So how do we solve for y? Looking at a standard first order differential equation, this is the expression we're going to use. So your y will always be equal to the integral of the integration factor times. Now we had to identify q of x. Q of x comes in here now. Q of x dx, all divided by the integration factor. The integration factor, guys, is not dividing what is inside the integral. It is dividing the entire integral. That is very important for you to look at, okay? Maybe let me make a note here. So I'll say here, note that mu divides the integral, not necessarily what is inside there. Some people make a mistake and then they end up canceling stuff when that is not supposed to happen. You first need to go and solve this integral before you can start doing your division. Okay, that is very important. So let me make a note that what you should do is solve the integral before dividing. What did I do now? Divide. Before dividing, that is what you should do. Solve for that integral first. So this, guys, high level is all what you need for you to be able to solve a linear differential equation, or a first order at least. And the reason why this is important, you will see when you get into your week 2 of doing maths. When you then solve for differential equation, you will see them saying, use the first order repeated method to solve the DE, differential equation. And whenever they use such words, guys, you will see that they can even give you a second order differential equation, but you still need to be able to solve it as a first order. So you can be given a second order DE that you need to solve as if it is a first order differential equation. So it is very important that we understand how to solve a first order DE, because they will give us a second order DE. Then once they use these terms, you'll remember me, you will know that I need to solve this differential equation as a first order differential equation twice, because it's a second order. The third order, meaning the highest derivative is their derivative, it means you will solve this problem as a first order differential equation, but you'll need to do 3 rotations for you to get the correct answer. Do you guys understand what I said so far? Story time. Give me a thumbs up if you do. And
excuse me, I can't see your screen.
Right. You can't see my screen. Are you guys able to see my screen? Just give me a thumbs up. Yeah, so I think what you should do is just exit and join again, okay? Other guys can see it. So I'm going to take questions, guys. What is it which you don't understand that I said so far? Because when we go to problems, we are applying exactly this thought. I see we have a hand from Tanya. You can go ahead. Am I pronouncing your name properly? Okay, I assume you were giving me a thumbs up. No problem, guys. So to see if we actually understood what happened here, we are going to have a series of problems. Okay. So let's go. So the first problem that I have for you here is we need to determine whether the differential equation is linear or not. So can we guys agree that this is a first order differential equation? Why? Why is this a first order differential equation? Anyone, guys? Should remember how I defined a first order differential equation. I see we have a hand from Samantha. You can go ahead. Why is this a first order? Okay. I cannot see your response, but let me give this a shot. Anyone, guys, who wants to give this a shot? Is this a first order and why? Anyone? You can go ahead. I see a hand from Samantha.
The
Okay.
dy dx is to the power of 1.
What do you mean dy dx is to the power of 1? Okay. To come to what you are saying, here's what I'm going to ask you. If I have this here, okay, if I have this here, is this a first order or a second order differential? So I'm asking this because we need to be very careful. This is still a first order differential. Okay, but anyway, this one here is a first order, guys. Why is it a first order? It is because the highest derivative is the first derivative. Is the first derivative. That is why. So that is why this is a first order. The highest derivative is the first derivative. Okay. So now let's quickly figure out, is this a linear differential equation? So we know it's first order, but is it linear? Well, we know that if it is linear, we should be able to write it in the form of dy dx plus p of x times y equals q of x. So looking at our problem, you will see that our problem is x minus dy dx equals x times y. So we can do some transposing here such that we get negative dy dx minus xy equals minus x. And you guys should be able to see that we can actually create some space. We can just divide by -1 to get this to be in our standard form. Okay, so if you observe carefully, we can come here and divide by -1, divide by -1, divide by -1. And our answer, therefore, will be, if you observe carefully, dy dx plus xy equals x. So the question, guys, is this linear? Okay, so I'm going to say this is linear. It looks like what we introduced as a linear differential equation. So we'll see other cases where it will not be linear. Okay, now let's go for the second one and have a look. So my question to you guys is this first order or not? Anyone, guys? Is number 2 a first order differential equation or not? Okay, I'm gonna give it to you in the interest of time. It is a first order differential equation. Why is it a first order? It is because the highest derivative is 1, is the first derivative. So if you look at that y prime there, it is just dy dx, of which this is a first order differential. Okay, so it is definitely a first order problem. And now let's go to the second question. Is this linear? So, and we'll go into how we test linearity later, but plus xy squared equals square root of x. Is this, guys, linear? Given how you learned how the standard linear differential equation looks like, we copy it. So my question is that linear? What are your thoughts, guys? Are you saying this differential equation is linear?
Guys.
Anyone?
Are you saying?
Any volunteers, guys? Is this a linear differential equation or what? I see we have a hand from Sana. You can go ahead.
No, it's not linear because it's y squared, not y.
Okay, you're on point. So this differential, guys, is a first order, but it is not linear. Here's the problem. That term there is what makes it to be not linear. Okay, and we'll go and discuss what linear means later, but this is clearly a first order differential equation, but it is not linear. So what is this? This is a nonlinear first order differential equation. So it's very important that you are able to look at an equation and see that there's a problem with this one. Okay, let's go for the next problem, guys. Let's have a look at this one. So the first question we need to go and figure out is this a first order, of which you can easily see? But yeah, so is this a first order? And the answer is yes. You guys can see the highest derivative is the first derivative, okay? And now what I'm going to do is I'm going to arrange this and try to get it to be in standard form, okay? So I'm going to try get standard form and see if I win. So if you look carefully, what we have is dy dx equaling 1 over x plus 1 over y. If you just combine these, you will get x plus y divided by x, y, okay? And then what we can now do is you just do cross multiplication. Well, not cross multiplication. Yeah, we can't do that. So dy dx equals, if you look carefully, x plus y divided by x, y. So we can try and not have fractions. So when we multiply the other side, we end up getting xy dy dx equaling x plus y. So we know that usually we prefer the y to be on the other side according to our standard form. So now what I have is xy dy dx minus y. The x can afford to be on the other side. But what we know, guys, is that according to our standard form, we never want anything here in front of the dy. So what we'll do is we'll divide by xy, divide by xy, and then divide by xy, so that we don't have anything in front. So we end up getting dy dx, and then minusing, if you observe carefully, the y's will cancel, so it will be 1 over x equals, the x's will cancel, it will be 1 over y. So now my question, guys, is this linear? Looking at what you learned from a first order linear differential equation, how it looks, is this linear? Anyone, guys?
No.
Hey, it is not linear. So this, guys, here is not linear. And we'll get into later, how else can you show, as you get more complex problems, how you prove linearity. But we know our standard form, which is what we have here. And I need you to learn to look carefully at what is happening, okay? So if you look at our standard form here, you will see that we don't want to have y anywhere else except just y here. We have 1 over y there. So even if we do manipulation, it is not going to check out to be something like this. So this is not linear, but it is a first order differential equation. Okay, so it's a nonlinear first order differential equation. Let's have a look at this one now, number 4. So this one here, we can all agree that it is a first order DE. Why is it a first order DE? The highest derivative is the first derivative. So this is definitely a yes. Why a yes? We should mention the highest derivative is the first derivative. Okay, that is why. So now let's go and have a look at, is it linear or not? And your test one will have a lot of these problems where they say, show that this operator is linear and whatnot. But let's look at first order differential equations for now. So you have y sine of x equals x squared dy dx, and then minus x. So let's try and arrange this such that we can write it in the way which we are used to. So what I'm going to do is to just do some grade 9 maths. I'm going to take this as if I'm taking it this side, okay? And then I'm going to take this as if I'm taking it this side and flip them. What do I mean? Well, I'm going to have x squared dy dx minus sine of x times y, and then equal to positive x. So what we know is that in front of the dy, guys, we do not want anything. We like it when dy, the x is sitting by itself. So this x squared here is a problem. So we need to go and remove it. Divide by x squared, divide by x squared, and divide by x squared. So what answer do we get? We end up getting dy dx minus, if you observe carefully, you'll have sine of x divided by x squared, like that, times y equals, we'll have 1 over x. So knowing your standard form, guys, we highlight it for you here. Is this a linear differential equation or not? If you believe it is linear, give me a thumbs up. And if you think it is not linear, then give me a thumbs down. Okay, so when we look at the standard form, it looks like these things, they match. Okay, while we are on this, I need one of you guys to give me what is going to be our P of X equal to. Anyone? It's a simple question. What is P of X equal to, guys?
Is it not gonna be sine x over x squared?
Negative.
Or negative, sorry.
not forget the negative. So it's going to be negative sine of x divided by x squared. Thanks for that. Anyone else, guys? What is going to be q of x? Simple stuff.
1 over x.
Over x.
1 over x. Brilliant. So let's go to the, well, this was my last question for classifying. Okay, that's okay. Now, let's get into solving these problems, guys. Question 5, solve the following differential equation. Now you need to remember the steps that we undertook. So I'm going to remind you the first two problems. So number 1, what we can clearly see here, but before we even write number 1, we can all agree that this one here is a first order, which I hope we can all see. So this is a first order. Is that the truth? Yes, it is. And is this linear? And then at this point, I would not blame you if you say maybe. Your first step will assist you, but for the most part, you will not be dealing with nonlinear differential equations. So let's go to step number 1. Step number 1, if you remember, what I said we should do, guys, is to write in standard form. So write dE in standard form. That is what we want to do. What is standard form? Standard form is what we have here. This is what standard form is. So we should first attempt to write our dE in this way. Okay, so let's have a look at what is given and see if we can write it in standard form. Lucky enough, that one is already cleaned up. So our dy, sorry, should remove this now. So if you look at our standard form, it is going to be dy dx, well, not x, but t here. It's going to be dy dt, then plus 2t times y equals e to the negative t squared. So already this is in standard form. We are happy, okay? We go to number 2. Number 2, what we said, if you remember our steps, we need to identify what is p of x. In this case, our independent variable, as I mentioned, is t. Then we'll need to find p of t and q of t. So now what we need to do is to find what is p of t and q of t. Okay, so I'll need your help in the meeting, guys. What is p of t?
2t.
P of t is equal to 2t. What is q of t, guys? What is q of t?
E to the power negative t squared.
Okay, let me quickly check something. So you said qt is e to the power of
Negative t squared.
negative t squared. Okay, done with that. And then we are done with the step. Step number 3, if you remember, guys, what I said to you is that we need to find the integration coefficient. Find the, did I say coefficient or factor? Okay, I don't remember what I said, but let's find the integration factor. I'll check later what I said. That factor, guys, is given by mu, and this is equal to e to the integral of p of t dt. So this means that this is going to be e to the integral of, we are integrating our p of t, which is 2t. So what is our mu going to be dt, guys? What is it going to be? It's going to be e to the power of, anyone? we are going to have e to the power of what?
To the power of t squared.
Okay, to the power of t squared. And remember, guys, I said to you earlier, you don't need to do this plus c. Just leave it. It does not matter. It will eventually cancel out, okay? So you can leave it like that. So our mu just becomes e to the power of t squared. Then once we find this integration factor of ours, we are ready to go and solve for y. So we need to go and solve for y. This speaks to answering the question which we are given. And I told you previously that your y is simply given by the integral of the integration factor times q of t dt divided by what our integration factor is. So this will be the integral of, we found above here e to the t squared. We know that our q of t is e to the negative t squared dt, and we are dividing all of this by e to the t squared. Okay. Now, if you observe carefully, guys, you should be able to see that what we are integrating inside there will simply be e to the power of 0 dt, and we know e to the power of 0 is just 1. So this will end up being 1. But remember, so you are integrating 1 dt divided by e to the t squared. So when you're integrating 1, guys, you should remember that what you will get is t plus c. Okay? And then this is divided by e to the t squared. So we can take the e now and push it to the numerator. So what it's going to be, if you think carefully, it's going to be y equals t times e to the negative t squared plus c times e to the negative t squared. This, guys, here becomes our answer. Do you guys understand? If you do, give me a thumbs up. If you don't, please ask. Okay. Any questions, guys? Right. I see we have thumbs ups. There's no question, then let's move to the next problem. Okay. Let's have a look at the next
Sir,
problem.
can you
Yes.
please go back for like 5 seconds? I just need to copy down the final answer. Thank you.
So let's have a look at the next question, which is question 6. So for question 6, we are told solve the following differential equation, and we are given that. So the first thing that we should do is to write this in standard form. Okay, number 1, let's go ahead and do that. Write in standard form. So already, lucky enough, this is in standard form, so we'll copy it as it is. So we have dy dt minus, what I'm going to do is, so that I'm clear what is multiplying y, I'm just going to say 1 over t squared plus 1 times y, and this is equal to 1 over t squared plus 1. So this is already in standard form, and we are happy. Okay, then let's go to number 2. For number 2, what we need to do is to find what is our p of t and our q of t. So someone in the meeting, please give us what our p of t is.
Negative 1 over t squared plus 1.
Okay, let's go for q of t, guys. What is it? Simple stuff, guys. Your Q of t will be 1 divided by t squared plus 1. Okay, done with that. Let's go to step number 3. Step number 3, what we want to do is to find our integration vector. And that is that funny sign, mu. So this is always given by, we have a formula, it is e to the power of the integral of p of t dt. So which means in our case, we have e to the integral of minus 1 over t squared plus 1 dt. So for this one, guys, I need your help in integrating or in performing that integral. So what is the integral of negative 1 divided by t squared plus 1 dt? What is this integral? Remember your first year stuff. What is this?
Is it negative arctan t?
It's going to be negative the arctan of t. Okay, that is what we have. So now, if we go back to our mu, what we essentially have is e negative arctan of t. Okay, and then let's now go and determine our y. So step number 4, we need to solve for y. So how do we solve for y? Well, we have an equation that we use, which is y is the integral of mu times q of t dt, all of this divided by this vector. So let's go and plug and play. So the value of y will be the integral of e to the negative arctan of t multiplied by our q of t, which is 1 over t squared. Sorry, t squared plus 1 dt. Okay, and we now need to integrate this, guys. So my question to you is, how do you think we should integrate this? First year stuff is creeping in also. Well, I need to do my division here by all of that. So let's copy this. Any thoughts, guys? How do we solve this? The top part there, that integral, how can we deal with it? Any takers, guys? The green integral, how can we solve that?
Can't we use integration by parts?
Maybe we can. So how would you use integration by parts here? So integration by parts, do you remember that it requires one of the functions to be easier to integrate, one of them to be easier to differentiate? Let me think. Would integration by part work here? It's going to take us in circles. So here's what we can do. What we can do, guys, is we can use U-Substitution. But I need you to go and figure out other ways to deal with this problem. So what I'm going to do is I'm going to let u to be equal to that negative arctan of t, such that my du dt then becomes negative 1 over t squared plus 1. Okay. This is what I have. But then if I multiply the other side by dt, you will see that negative du will be equal to 1 over t squared plus 1 dt. What does this mean? What this means, guys, is that I can go up there where I see this here. I can replace it with negative du. And then I'm now integrating e to the power of u. Do you guys see the magic here? Maybe yes, maybe not. It's beautiful. So look at what is happening. Our y now has become the integral of everything that was on the power of e. I chose to make it to be u. So meaning I'm now integrating e to the u. And that part, which is this one here, I made it to be negative du. So I can put in a negative here, then put in du. Okay. Then I chose this part here to be u. So I'm just dividing by e to the u. So if you observe carefully, we're integrating e to the u. So that is going to be negative e to the u plus c divided by e to the u. And if you observe carefully, you will see that these will cancel. I'll be left with negative 1 plus c times e to the negative u. So let's make some space. So I'll be left with e to the negative u. Okay. So therefore, our answer, guys, y is simply negative 1 plus c times e to the power of, remember our u was negative that, meaning now my answer is just going to be arctan of t. Do you guys understand what we did here? So this should remind you that you should make sure you recap those basics of integration. So if you understand, just give me a thumbs up. If you don't, please ask. So that there becomes our answer. Maths is nice, guys, isn't it? Very nice. So let's go and have a look at the next question. Very easy as long as you remember your fundamentals. Let's have a look at this one. Why did question 8 move here? Let me see. Next. Okay, I'll deal with that later. Let's have a look at this one, guys. Solve the following differential equation. So now you know the steps, but let me still write them anyway. So the first thing what we are going to do is to write in standard form. And for most of these equations, you will find them written in standard form, but just, reorder them if needed. So dy dx plus, so I'm going to look at what multiplies y. It is 3x squared. That is everything that multiplies y, and then we have 6x squared. Done. Then number 2, we need to go and find p of x and q of x. So people in the meeting, what is p of x, guys? Any volunteer? And what is q of x?
3x squared.
P of x is what?
Never mind.
I cannot hear you guys. What is px?
3x squared.
Px squared. And then what is q of x? Q of x is 6x squared, guys. Thanks for that. You can now, guys, mute. The next one. Someone is okay. Check your mic. I think it is Nash. Let's look at your mic. Thanks. So next, guys, what we need to do is to find the the integration vector. So what is that integration factor? Well, there's a formula which we use. It is given by e to the integral of p of x dx. So this means that we'll have e to the integral of 3x squared. So what is it going to be, guys? Our mu is equal to e to the power of what? Well, I need to put dx here. What is it? What is the power, guys?
X cubed.
X cubed. And just again, there is no need for you to write the plus c. It's just going to stay there and complicate your life if you easily get confused. So just leave it out. Then let's go for the last step. Step number 4, where we solve for y. And what this problem also will show you guys is that you need to go and revise your substitution. It's very important. So your y is equal to the integral of this times q of t dt divided by that. So for our problem, what we have is the integral of e to the power of x cubed times 6x squared dx divided by e to the x cubed. So I want you guys to assist me to figure out what is this integral equal to. Let's take it down and focus on it. How can we solve this integral? With the least effort. Our aim is to be lazy, but lazy smart. So how can we deal with this integral, guys? So one of you must help us here. Otherwise, we start.
Maybe if we let x cubed equals to u, we differentiate.
Okay, so let's take your suggestion. So what he's saying is saying that let's go and use U-Substitution. And I need you guys to go and revise this. And when you revise it on your previous course, it is under direct substitution. This will be very important for your maths too. So make sure that on your notes, you do make a note that I need to go and revise something that is called direct substitution. Okay? Very important. So let's go ahead and do U substitution. So we'll have our U. Oh, I don't want that thing anymore. 3. What did I do now? Okay. Strange things are happening, guys. Just give me a second. This is very important to highlight. Okay, and then let's go into our U substitution. So our U should be x cubed. So this means our du dx will be 3x squared. Okay, so what does this mean? It means that wherever I see, I'll just multiply by dx, the other side, such that I have du equals 3x squared dx. What does this mean? This means whenever I see 3x squared dx, I can replace it with du. So look at us trying to be smart, because we are. So I have e to the x cubed times, I'm going to pull out a 2. And then now I have 3x squared dx. This here, I can clearly see that this will be du. And then the top part there on my exponent, this one here is simply u. So this means what I'm integrating is 2, the integral of e to the u du. So this here has just become that. So we go there at the top, we say our y equals 2 times the integral of e to the u du. Then my denominator, remember, I made the x squared to be u, so I have e to the u. When we integrate e to the u, we get e to the u plus c. We divide by e to the u. Then you can do some cancellation here. You'll be left with 2 plus, let me create some space. You'll have 2 plus c times e to the negative u. So we can now finalize our answer below. What is our answer? Well, it should be in terms of x. So our y will be 2 plus c times e to the power of, remember our u is x cubed, so it is negative x cubed. Then if they give us conditions, we can obviously solve for c. Do you guys understand? If you do, give me a thumbs up. And if you don't, please ask. Okay. You can see we have a lot of thumbs ups, so it means we're doing well here, isn't it? Right, let's go for the next one. I think this is the second last. Okay, let's see. What did I do? Okay, let me just leave it there. Let's have a look at this one, guys. Very easy. What I'm going to do is, because I already know the steps, I'm not going to write them again. So I see that this is a dy dx. And then plus, I see that I have 2x times y equals 1. Looking at this, I can tell that our p of x will be 2x and our q of x will be 1. So next, I'm going to find my integration factor, which is e to the integral of p of x dx, which is e to the integral of 2x squared, 2x dx, which will end up giving me an answer of e to the power of x squared. Let me see, did I get that correct? Yep, I did. And then now we can go ahead and find our y. So remember that your y is simply the integral of mu and then q of x dx divided by that factor. So this means what we are going to have is the integral of e to the power of x squared, then times 1 dx divided by, well, what it is, e to the x squared. So this is what we have, guys. Now I need your assistance with figuring out what is this integral here. What is the integral of e to the power of x squared dx? How can we solve this, guys? Any volunteer? Okay. So in the interest of time, I'm going to give you some hints. So what we can try and do is we can attempt to look at integration by, you guessed right, by parts. So what integration by parts is, guys, so it means you need to go and revise it. If you are integrating u dv, the answer you get is uv minus the integral of v du. So when you're dealing with integration by parts, you need to choose between two functions. Which one is easy to integrate? Which one is easier to differentiate? So when I'm looking at this here, e to the power of x squared dx, I'm going to make it to be the integral of 1 times e to the x squared dx. Then our u is always the function that is easier to differentiate than to integrate. So if you observe carefully, our u here should be e to the x squared, which means our dv will be 1. And guess what? we need to go now and find what is du. So du, if you observe carefully, it will be 2x e to the power of x squared. But the v will end up being x. So if you look at what our integral will be then, e to the x squared dx, it will be u times v. So if you observe carefully, u times v is x times e to the x squared, and then minus the integral of our v, which is x, and then times du, which is 2. So it will be multiplied by 2. So I'll just write it as 2x squared e to the x squared, like that. Okay? And then dx. So now this looks a bit easier, but can we integrate what we have there? And the answer is maybe not. What do you guys think? What should we do from here?
I think we can do another integration by part to the right hand side so that we can try to get e to the exponent x squared again and then do that thing.
Okay. Anyone else? Okay. So I need you guys to think about this. What I'm going to do is jump away from the problem. Yes, that is what I'm going to do. But the guys who are doing electrical engineering, this integral here, keep it in mind. The guys who are doing EIE, just keep this integral in mind. I think you'll see it very soon. It's very important for you. But for now, let's say I need you guys to go and attempt it. I'm really interested to see how you are going to find it. And here I'm going to say, especially the guys who are doing EIE. I want to see what they will find, and then they will eventually find out later in their course how to deal with such. Anyway, let's move, guys, to question number 9. I think I have up to question 10. Then we'll speak about operators. So with question 9, very easy, guys. We have dy dx minus, so what I'm going to do, it's minus y equals e to the x. Then if we look at our p of x, you should see that it will be minus 1. And if you look at your q of x, it will be e to the x. So I'm just writing this under the assumption that you understand already. So we can now find our factor, which is e to the integral of -1 dx, which the answer will end up having is e to the negative x. And guess what? Once we find this, we can now go and find y. So our y is always equal to our factor multiplying our q of x dx divided by the same factor. So what this means is we have e to the negative x times e to the x dx divided by e to the negative x. So if you observe carefully, you will see that on the numerator, all what we'll be integrating is 1 divided by e to the minus x. And when you integrate 1, you end up getting x plus c divided by e to the negative x. And you will see that our final answer, y, will simply be x times e to the x plus c times e to the x. Do you guys understand? If you do, just give me a thumbs up. And if you don't, please ask. Okay, I see we have a lot of thumbs ups. So let's go to the last question for linearity is, which is question 10. Okay, it's going to be a very interesting one. Okay, let's go. So the first thing I need to realize is that this is not in standard form. So one, what I need to do is to write in standard form. Okay, so let's go ahead. What we have here is x dy dx minus 4 times y equals x to the power of 4 e to the x. What is the problem here? The problem is the x which is in front of the dy dx. So we need to remove it. So let's go ahead and remove that x there. So I need to divide by x, divide by x, divide by x. What do we get? What we end up getting is dy dx minus 4 over x, minus 4 divided by x times y equals, if you observe carefully, x cubed e to the x. So now, guys, what is my p of x here? And what is my q of x? Anyone? You keep quiet for long, you will fall asleep. What is p of x here?
Negative 4 over x.
Negative 4 over x. And what is q of x? Where's one of the ladies here? Take it for the team.
X cubed times e to the exponent of x.
Yep, x cubed e to the power of x. So now we need to go and find our mu, our integration factor. So this is always given by e to the integral of p of x dx. So for our problem, we have e to the integral of negative 4 over x dx. Our mu will be equal to e. When I integrate that exponent, guys, what do I get? When we integrate the exponent, what do we get?
Is it not negative 4 ln x?
Okay, negative 4 ln x. That is correct. Okay, and how can we simplify this, guys? There is a way. There's a way. Anyone? This does not look appealing, isn't it? So the question should be, how can we solve or simplify this? Any thoughts? Okay, so how this is going to be, guys, is it's going to be e to the ln of x to the minus 4. It is basic exponential laws. So you guys know by now that e to the power of ln of a, what is it equal to? E to the ln of a is equal to what, guys? I think we did this a lot in AP Physics. What is this equal to?
A.
Is equal to A. Yep, you guys should get A's. This is very important for you to remember, okay? Because if you didn't, it was just gonna look like a hellish problem. So if you look carefully, remove that. So if you observe carefully what is inside, we know it will amount to x, and then we have -4, which means our factor is just 1 over x to the power of 4. And guess what? Next, we are going for y. So we know that y is the integral of our factor with q of x dx divided by our factor. So this integral becomes 1 over x to the power of 4 times our q of x, which is x to the power of 4 times e to the power of x dx. Let's create some space. Right. So if you look carefully, you will see that there's cancellation of terms here. So this one and this one cancel. Well, divided by 1 over x to the power of 4. So your y, you will see that it's just the integral of e to the x dx. All of this is divided by 1 over x to the power of 4. So when we integrate, we'll end up getting e to the x plus c divided by 1 over x to the power of 4. What is the final answer? Well, 1 over 4 will be the same as multiplying by x to the power of 4. So this will end up being x to the power of 4 e to the x plus c times x to the power of 4. This here, guys, is our answer. If you understand, please give me a thumbs up. And if you don't, please ask a question. There is no in between. Okay, I see we have a hand from Dumisani. You can go ahead.
I wanted to ask you, did you make a mistake there when you substituted GFX? You said X is a four partition.
And can you come closer to your phone?
I think there's a mistake here when you substitute Q of X.
Okay, let me. So you are saying you think there's a mistake where?
When you substituted Q of X to the integral.
When I substituted into the integral, what mistake is there?
Q of X should be X cubed and not X to the exponent of 4.
X to the exponent of 4. Okay. Anyone, guys, who can hear them clearly, who understands what they are saying? I think your mic is, yeah.
Sir,
Yes.
he's talking about the q of x. When you wrote the two equations, p of x and q of x equates x to the third power times e to the x. But then when you transferred it or rewrote it on the integration, you used x to the fourth power instead of x to the third.
Okay, so I need to take the 3's and make them to be 4's here. Is that correct? Okay. Yep. That solves our problem.
Didn't we divide by x? So wouldn't you have to take the 4's and make them 3's?
We divided by x, so the 3's are correct. Okay. I'm losing my train of thought. So, well, this means more work then. Yo, anyway, okay, let's go and give it a shot, guys. Thanks for that. You know, the brain converges to what is so convenient. It is so happy when it wants a 4 there. Anyway, so this means we need to go and do the hard work. So the shortcuts are not working, guys. So our y will be, thanks for that, it will be the integral of, so I'll just leave it as 1 over x times e to the x dx, all divided by 1 over x to the power of 4. So let's go to the next page and deal with this integral. So with this integral, guys, I need your thoughts. How can we solve this one here? You guys have done your first year and you passed and all excited and smart. How can we solve this? I see we have a hand from Lutendo. You can go ahead. You can go ahead. How can we solve this one? Anyone, guys? How can we solve for this? I'm going to take a wild guess and then say, maybe we should use integration. Should it be by parts? Would this work? Let me think. Maybe it can. Okay, let's have a look. So let's try integration by parts and see how it goes. U dv equals uv minus the integral of v du. Okay. So what should I choose as my u and dv or v here, guys? Anyone? What should we choose here? Any takers? So with such a problem, guys, what you should do, are you giving it a shot?
U is 1 over X.
What should I choose 1 over x to be?
U. It make U 1 over X.
Okay, why is that? It's a smart choice, by the way, but why? Are you still there? So making u to be 1 over x is a smart choice. But why are you choosing that? Then dv will be e to the x. I'll wait for your response. Then du will be minus 1 or minus x to the negative 2. And then our v will be e to the x. So what this means is our integral 1 over x times e to the x du will simply be u times v. This will be 1 over x times e to the x minus the integral of v du. So if you observe carefully, I'm going to put a plus and then say x minus 2 e to the x dx. Okay. Now I need to choose again, guys, here. What should I choose as my u and what should I choose as our dv? Anyone? So even here, we need to choose u and dv. So I need you guys to think carefully. What should I choose as our u and what should we choose as our dv?
U is e to the X.
So why should we not choose u to be x to the negative 2 here? Why? Why are we not making u to be x with a negative 2? Okay, so let's choose our u, guys, to be e to the x. And by the way, again, that is a smart choice. But I'm not sure if you understand why you are choosing these the way you are. You understand?
Yeah, I do understand.
Okay, please explain to the others why you are choosing these the way you are. What are you seeing which we are not seeing?
And also when we choose U, we choose the one that is easier to differentiate.
Mm.
Yeah, in yeah, go retrieve, that's why I've distracted Kama.
Okay. So what is happening, guys, here, his choices of you on the first shot was correct, and also on the second shot. So the idea here is, and with practice, you'll easily be able to see how to choose these things. If you choose U again to be the X to the -2, you will differentiate it. It will go to a -3, and you still will not be able to integrate that. But if we choose it to be dV, when we integrate, we are bringing it back to 1/x. And we will do some integration, which you learned from first year, where you are now transposing an integral, it adds up with another one, and you end up dividing. So long story short, our du will be e to the x, and our v will be, if you do the integration here, -1/x. So what does it mean? It means that the integral which I have here, du, it is going to be u times v, which is going to be -1/x, times e to the, I'm doing u, v times u, yeah, e to the x like that, and then minus. If you observe carefully, what did I say? Let me think of what I did here. We are supposed to do v times u. Where is v times u? So this is going to be a plus now. 1/x e to the x dx. Let me see, if we take this integral, we plug it there, this is going to give us 0 equals 0. That is true, but that is not what we want. Did I make any mistakes, guys? So if you look at this integral and you take it, you plug it up there, back, du, and then v, it will end up giving us 0 equals 0 if you observe carefully. And that is not useful. So what should we do?
Can I please ask a question?
Yep.
On the first part where we chose our u and v, why couldn't we use e to the power of x in the first place?
Let me go back to that. So you are saying, why could we not use u as e to the power of x?
Yes, because if we went back, you could have given us a ln
Yep.
for v.
So if you take u and you make it to be, well, you are saying we should take, oh, yeah, you are saying we should make u e to the x, which means dv becomes 1/x, which means du is e to the x, which means our v is ln x. Okay. And then this here will then become the integral of 1/x e to the x dx, u times v. This will be e to the x ln of x minus our v du, so which means e to the x ln of x dx. Okay. And then you still need to deal with this. And from this one, we can agree that it is not easy to integrate ln. So I expect that you choose your ln to be u, and then you choose your dv to be e to the x. See if this will check out. Then your du will be 1/x, and your v will be e to the x. So this means that integral there, e to the x ln of x dx will be u times v. Which is going to be what? E to the x, ln of x, and then minus the integral of what? v du, which is just 1 over x, e to the x du. So if you think carefully, if you take this here and you go and plug it there, it gives us 0 equals 0. So this integral here seems to be circular. So very weird. Let's put a star on this. Do you see the problem that it gives us the same problem? If you take this here and you go and plug it there, it will say 0 equals to 0. It tells you that this is equal, but we can't solve for it. So I'll put a star here on this problem. But definitely you will not get anything that will result in you doing circles and circles and getting that what you know is the true, like 0 equals 0. So those one-nets can go and give it a shot and try it as homework. Currently, what it's doing, this integral, it's taking us around to say 0 equals to 0 when you substitute this even here. This side with the same problem, if you take that and you put it there, you end up getting 0 equals 0. Okay, interesting. So let's pass this, guys, and then move to the last part of this lesson. And the last part has to do with something that they call operators. So I'll try and keep it brief. So for operators, guys, we have a couple of operators that you should be aware of. So you should remember that we have an operator that is called the integral. So the integral, which you know by the sign here, is an operator, okay? And then you have another operator as an example, which I will call a differential. The differential operator, which you famously know as, let's say, dx. Okay, and there's many other operators that you should be aware of, like, I'll give you an example, like the sigma operator. So an operator just does something on something to give you something. Like even this one is an operator. Multiplication is an operator too, and many more. So multiplication also is an operator. But our focus more for your course, guys, will be on what you call linear operators. So the question you should ask yourself is, when is an operator linear? And this will just be answered in 2 points. When is an operator linear? So when is an operator linear? What we are going to do for our operator, we'll use P. That will be our operator. So number 1, an operator is linear if when it acts on y1 plus y2, it gives you the same answer as when it acts on y1 separately and acts on y2 separately, but the sum will be equivalent. Okay, this guys here, they call it superposition. I think we have done it in AP physics. So an operator must satisfy the superposition. Let's call it rule. Okay. Then secondly, it must satisfy both of them. When is an operator linear? It must satisfy, in fact, this is not superposition. This here, let's call it the summation. Superposition is when we combine both of them. So summation rule. Yeah, that is more correct. Then number 2, what we need to do is to make sure that our P of, let's consider as a scalar, which is alpha, and our operator is acting on Y. You should get the same answer as when alpha is outside and the operator is just acting on Y. This here, we will call it the scaling rule. What should you know? For this to be linear, for an operator to be linear, both rule 1 and 2 must be met. So our rule 1 and 2 must be met. So not one, but both of them. That is how we know that whatever operation that we are using to perform, or whatever operator that we are using to perform an operation, that will be linear. So this is very important for you to understand. So let me give you an example. I'll call it example 11. So if you find yourself in a situation where you are required, if you remember from first year, you are required to differentiate, let's say, x cubed plus 3x squared. This we know that you can easily differentiate by simply dropping the 3, and then you have x cubed, and then you drop the 2, then you have plus 6x. Okay, you didn't do anything, you just derived it as it is. But someone else would have said, I am going to go and separate this. I'm going to go and say, I'm going to separate this x cubed, derive it by itself, and then separate that and derive it by itself, as if it's going to make a difference. The first part here, we know when you derive, it's going to be 3x squared. The second part, we know as part of what we learned for differentiation, a constant, you can always take it outside. So you can now have 3. Then what you are deriving inside is x squared, which becomes 2x. And if you look carefully, the answer becomes 3x squared plus, if you observe carefully, 6x. So we get the same answer. Now, let's have a look at more generic problems, because for your problems, you will be asked to prove if a certain operator is linear. But before I do so, do you guys understand what I said so far here? Okay. So if you, I can see we have some thumbs ups. So if you understand, then I'm going to push the idea of D operators to you, and then we have a look at maybe 5 examples. So, but keep this in mind about linear operators. It's here, all of this gold. You should make sure that you keep it in mind. Okay. So I want to introduce you to something briefly, which is called D operators. Then we'll come back to linear operators and combine with this. So some of you have watched videos already. So the D operator, all what it is the D is for differential. So in other words, for Maths 2, the D is just a fancy way of writing D dx, or the D is just a fancy way of writing D dt. Nothing deep. So meaning whenever you see dy, all what this is dy dx. Whenever you see dy, depending if the independent variable is t, this might just be dy dt. All what it is it's just a differential operator. That's it. Okay, that's the differential operator. So you already know how this works, the d, because all what it is d dx or d dt, depending on what the independent variable is. Okay, so now the first question I want to bring to you, which I'm going to call it example 11, comes from your tutorials. So with this example, what we are required to do is to show that, so we are required to show that d squared, sorry, d squared plus 3d plus 2 is a linear operator. So this speaks to what I introduced to you. We need to show that this is a D operator. So how are we going to do this? Well, the first thing, we are going to take this polynomial here and say what we have is a polynomial in D, which means D squared plus 3D plus 2, okay? So what we then want to do is take this polynomial, go and make it to act on these two conditions. So remember, we said that we can act on y1 plus y2 and then see what happens, and then do the same, and so on, and so on. So remember, it means what we are going to do now is we are going to do P of D, but P of D is going to act on y1 plus y2. What does this mean? This means that you have D squared plus 3D plus 2. So if you think about this carefully, you'll be acting on y1 plus y2. If you have a look at this, you will end up having D of, this here will act on every part which you see here. So you'll end up having D squared of y1 plus 3D y1 plus 2y1 plus, then now y2 starts acting on every term which is here, which becomes D squared y2, then plus 3D y2, and then plus 2 times y2. If you observe carefully what has happened there, is we actually have now, when you now look at this part here, you can see that what we have is just P of D of y1. Or if we were just calling, or if we were calling this, let's maybe just call it P so that maybe it looks a bit neat. Yeah, if we call it P only, then we can afford to do this. Let's call that operator P. Yeah. So if you observe carefully, the first part now has just become P of y1. Then the second part is just become P of y2. So if you look carefully, that summation rule that we spoke about is met here, because the D will always, if you have Y, if you have D and Y there, this will always be dy, because we remember that the D is just the dx. So it must always be attached to something here. So the summation rule has been met. And then now we need to think about the other one, which is the scaling. So we know that our P is the same as D squared plus 3D plus 2. So it means now we need to do P of alpha y. So what does it mean? It means we'll have D squared acting on alpha y, and then plus 3D acting on alpha y, and then plus the 2 which is there will be multiplied by alpha y. So if you observe carefully, you will see, we remember that with derivatives, a constant, you can pull it out as is. So if we pull out the constant here, you will see that this is the same as having alpha into D squared acting on y plus 3D acting on y, and then plus 2y. And this here just becomes P of D. So it means P of alpha y, this will now become alpha. What we know is that that is the same as P of y. So this means that the scaling rule here has been met. Do you guys understand what I did here? Or maybe not? Okay. So let me show you one which is not going to be, let me think. Yes.
May you please explain the summation rule example again?
Okay. So with the summation, what you need is if you act on a sum of two things, if the operator acts on a sum of two, let's say functions of interest, it should give you, not if it's linear, but for number one, you should get the same value as if you acted on one function and then plus you acted on the other function. This two is not supposed to be there. That is the idea. So it's like when you are differentiating that example that I gave to you. And I said, the differential operator is linear because if I have f of x here, you were taught that this is the same as if you go and derive f of x, and then you derive the g of x and you sum them, you will get the same answer. Do you remember that? So d dx and then g of x. So the question is, if I start off with a sum like this, would it be equivalent to that? If the answer is yes, then it means the summation rule has been met. Still confused?
No, sir. Thank you.
Do you guys understand a question or a thumbs up if you do, and a question if you don't? I'm looking for a problem which is going to be non-linear, where this is going to fail so that I show you what is happening. Let me see. I can't see one here from your book. Yeah. So what I'll do, guys, is I'll look for a problem where it is not going to be, okay, here's one. Yes. Yeah, let's have a look at this one. Okay. So let's say we have let's say we have this case here. I'll call it example, I think 13. Yeah. So let's say now what we are asked to do here is to check if this operator, let me think. Like y, and then it's going to be squared. Yeah, this is also going to check out. Yeah. No, guys, let me go and look for operators where it is definitely not going to be linear. To be linear, and then we can then discuss them. But maybe a question to you guys is, do you have any questions that you have for me? And what I want you to go and try and do is, now that you understand these first order differential equations, you should go to your actual textbook. And then what you should do is go and attempt to solve those D operator questions, which are first order. You will see that some of them are written, will deal with the null space and other things. Oh, in fact, here's a problem. Yep, I found one about linear operators. Let's have a look at it. Yeah, let's call it example 13. You'll check it out from your book. Okay, so we are asked to determine whether the operators are linear or not. So we are asked to determine whether the operator is linear or not. And what we are given is that P of y equals y squared. Okay, so what we know, guys, we know that I need to do two tests. The first test that I need to pass is that when I'm acting and this is your tutorial question. So the first test is that if I impose y1 plus y2, I should get the same thing as if I have p of y1 plus p of y2. Okay, so now let's go to and use our operator, which is given. So we have p of y1 plus y2. And this should be equal to, on the other side, I'm given y squared, which means I need to put y1 plus y2 all squared. If you quickly square this, you will get y1 squared plus 2 times y1, y2 plus y squared. So is this, guys, matching what is above? And if not, where is the problem? So can we agree that this is behaving as if it is p of y1, looking at the formula of p of y? You guys agree? Give me a thumbs up. Look at the formula of py, and then see that that y1 squared behaves exactly like p of y1, right? Then if you look at this one, it behaves like p. It is as if we went to p of y, then we just put y2. The problem is this one. This is the problem term. This is the problem. Why is it a problem? It's a problem because it's an extra term. So what then does this mean? It means that our p of y1 plus y2 is not equal to our p of y1 as we would expect plus p of y2. They are not equal because there's an extra term. So do you guys see that this is definitely not linear? So our conclusion here is that this here is not linear. It has failed one of these tests. But let's go and have a look at test number 2. So for test number 2, what we require is that if I have p of, because I'm given p of y, it means if I have p of alpha y, I'm expecting alpha p of y. The scale factor should be able to be outside. Okay, let's go and give it a try. So I'm given p of y equals y squared. So this means I'm going to have p of alpha times y. On the right-hand side, I'll put in alpha times y, wherever there's y, put in a square. Then I have alpha squared times y squared. What is the problem here, guys? Anyone? What is the problem here?
Is it because it's alpha squared?
Yep, this here square is the problem. We were not expecting that it should be alpha squared. It shouldn't be. So our conclusion, even the second test, tells us that this one is definitely not linear. So our conclusion will be that the operator, which is p of y, it fails test 1. Test 1 and 2. Then what does that mean? It means that this is not a linear operator. And that is it. You guys understand? If you do, give me a thumbs up. And if you don't, please ask. Okay, I see some thumbs ups. Let's have a look at example 14. Just to make sure we cement this. So the question is this linear or not? And remember, what we are looking at is the operator that we are given. So you'll be given an expression and they will tell you this is an operator. So the one that I'm given is p of y equals y times y dash. In other words, it is y times dy dx. Okay, we need to figure out, is this a linear operator or not? So we'll try the first test. What does the first test say? It says go and try and put in y1 plus y2 and see if the answer which you get is p of y1 plus p of y2. Okay, this is the first test. So let's go wherever we see y, we are going to put y1 plus y2. So we'll have p of y1 plus y2 equals, wherever there's y, we do y1 plus y2, and then derivative of y1 plus y2. And then if you look carefully, you can easily multiply these, but let's maybe start off by having y1 plus y2, and then dy1 dx plus, we know we can write this as dy2 dx. So let's multiply this. I'll multiply y1 with dy1. So I'll have y1 and then dy1 dx. And then the middle term, when you multiply y1 with that, you will see we get y1 dy2 dx. And then when we multiply the y2 with dy1, you will see that what we will get will be plus y2 dy1 dx. Then the last terms, when you multiply them, what did I do? 1, 2. So y1 must also multiply here. So y1 dy2. Let me think. What did I? Okay, I did cover the term. Okay, so the next one is y2 dy1. And then I'm going to have the last term, which is y2 dy2. So the last term is going to be y2 dy2 dx. So which terms are a problem here, guys? Anyone? So can we agree that the first term, this is the same as P of y1? Do you all agree? If you do, give me a thumbs up. That when you look at our formula and you look at that, that corresponds to Py1. Okay? Right. And then if you look at the last term, what does it correspond to? Anyone? What does the last term correspond to, guys? Anyone?
PY2.
Py2. So what is the problem here? Because we have our Py1, Py2, so is this thing checking out? Is it checking out, guys?
No, because the middle terms are not PY1 or PY2.
Yep, the middle terms are causing extra terms because all what we need are the terms which we've highlighted, but clearly there's more. So that is where the problem starts. So that is our problem. So this cannot be linear. It has failed test one. Whether it passes the second test, it doesn't matter. But let's go to the second test. So test number 2, what we say is that if you have an operator, when you put in alpha times y, you should get alpha and then p of the operator acting on y. So let's go and try this on ours. So it means I'll have p of alpha y. So what I have is wherever I have y, alpha y, then derivative of alpha y. You guys know that whenever we have a derivative, this we can take out, okay? And if you observe carefully, our p of alpha y will end up being alpha squared times y, and then dy dx. But when I look carefully and look at my original equation, I see that no, this one here is just py. That part is py. Then there's another part there that I need to write. So what is my answer? My answer is p of alpha y equals alpha squared p of y. What is the problem here, guys? So we write that p of y. What is the problem here? Anyone? What is the problem here?
The alpha is squared.
Yep, this here is the source of our problem. Our test says when we take out the scalar factor, it should not be squared. It should be as we put it in there. So that is the problem here. So our conclusion is that what we are given here, P of y equals y dash is not a linear operator. So that is how you should explain these problems. Guys, you do those two and then you will be done with proving whether this is linear, whether it is not linear. Do we have any questions, guys? Do you understand? If you do, give me a thumbs up. And if you don't, you can ask a question. I think we are gonna pause here if there's no question for me. And we'll work next on algebra unless there's follow-up questions from this one. So remember, this was just an intro to just try and give you a